Okay, hi. Our group will be presenting a case study on the Francis Scott Key Bridge collapse. On March 26, 2024, the MV Delhi, a large cargo ship, lost power and steering control shortly after leaving port. It struck one of the bridge's main piers, causing the central span to collapse almost instantly and killing 6 workers. The main purpose of this study is to understand what caused the Francis Scott Key Bridge collapse, not just from an engineering perspective, but also from an ethical one. We want to examine where technical failures occurred, how risk assessment were handled, and what responsibilities engineers and authorities failed to meet. This case is also connected to the Engineers Act 1967, which emphasizes our duty as engineers to protect public safety, act ethically, and maintain professional accountability. Our discussion will be focusing on 4 areas: how the incident happened, its human and economic impacts, the government's emergency and legal actions, and the engineering and ethical lessons we must learn. In this case, we focus on 4 key discussion areas. First, we look at the sequence of events. The MV Delhi lost power and crashed into a bridge pier, leading to an instant collapse. Second, the human and economic impact: 6 workers were killed, the port was shut down, and billions were lost in supply chain disruption. Third, we examine the government response. A national emergency was declared, and investigations found the bridge lacked proper protection. Lastly, we identified lessons for engineers, especially the need for proactive risk assessment, multidisciplinary coordination, and always prioritizing the public safety.
My name is Akinai. I will be presenting Chapter 3, which is Technical Engineering Issues. The collapse of the Francis Scott Key Bridge reveals several critical engineering failures. First, no vessel collision risk assessment was done, even though the bridge stood over a major waterway. Being fracture critical, it collapsed entirely when just one pier was hit. The NTSB later revealed the risk of such a collapse was 30 times higher than normal. Second, the pier protection system was outdated and never upgraded despite increasing the ship sizes. The MV Delhi was far beyond what the original fenders were designed to withstand. Third, the authorities ignored American Association of State Highway and Transportation Official 2009 guidance to reassess all the bridges. This shows a serious failure to follow engineering standards and protocols. The incident wasn't just about structure, it also involved the ship's power failure. There was no coordination with maritime engineers, no blackout contingency, and no tugboat escort. Modern infrastructure required collaboration between civil and marine disciplines. Finally, worker safety was neglected. 8 workers were on the bridges, 6 died. There were no emergency alert or evacuation protocol in place. As engineers, we are responsible for designing not only strong structures, but also safe environments. In short, this tragedy was preventable. It reminds us of the ethical duty engineers have to uphold safety, adapt to evolving risks, and coordinate across disciplines.
Hi, my name is Nurin Fatiha binti Azmi, student ID 2011-89, and today I will be presenting about the 4 ethical reasons of failure involving the Francis Scott Key Bridge. There are 4 ethical reasons of failure that led to the collapse of the Francis Scott Key Bridge, which are neglected safety assessment, failure to prioritize public safety, lack of transparency and accountability, and also the ship's owner negligence. Since 1991, AASHTO has recommended vulnerability assessments for bridges like the Francis Scott Key Bridge, but the Maryland Transportation Authority ignored this guideline, failed to assess growing risk from large cargo ships, and withheld critical safety data, resulting in a structure that, according to the NTSB, was nearly 30 times more likely to collapse in a collision than acceptable limits. Other than that, both the ship's electrical engineers and the bridge's structural engineers violated their ethical duty to prioritize public safety by failing to implement known safety measures, leading to the catastrophic collapse when Delhi lost power and struck the bridge. According to W Top News, when federal investigators requested key data to assess collapse risk, MDTA admitted they lacked it, forcing the NTSB to gather it themselves, demonstrating a lack of transparency, deflection of blame, and a troubling focus on protecting their reputation over public safety. Last but not least, investigation has revealed that the Delhi had a known history of electrical issues, yet was allowed to sail without proper repairs or redundancy, leading to its failure near Baltimore. An ethical breach highlighted by the Department of Justice claims that the ship's operators knowingly dispatched an unseaworthy vessel, prioritizing profit over public safety.
Hi, my name is Rachel Diliani Kijulu with student ID 220105549, and today I'll share the key recommendations for the 2024 Francis Scott Key Bridge collapse in Baltimore, rooted in the Registration of Engineers Act 1967 and BM Code of Professional Conduct to protect Malaysia's infrastructure and prevent future failures. Here are 5 actionable recommendations to address the vulnerabilities revealed by the collapse. The first one, bolster continuing professional development or CPD. Engineers need skills to counter maritime risks, so we propose updating the CPD framework to mandate the training on maritime collisions mechanics, fendering system designs, and emergency coordination with port authorities. So this ensures structures can withstand vessel impacts like the MV Delhi's collision caused by the power failure. And the second one, to ensure regular audits of protective measures. So the bridge fendering system has been uninspected for over a decade and was inadequate. So the Board of Engineers Malaysia should enforce biennial audits of impact protection system, fenders, mooring dolphins, and energy dissipating components, with results published on the BM portal for transparency. The third one is the demand independent reviews for older structures. So the 1970s era key bridge lacked moderate impact assessments. So we recommend adopting ASCE Policy Statement 351 to require independent reviews every 5 to 7 years by evaluating the load impacts, hazard scenarios, and retrofit options to align older bridges with current safety standards. And the fourth one is to improve oversight with external reviews. So collaboration is critical. Major projects and older structures like the Key Bridge should be faced triennial assessments by independent teams of engineers, port officials, and marine experts following the AAS HTO model. And publicly shared the findings will drive accountability and swift corrective action. And the last one is to launch a real-time risk and licensing platform. Immediate data access is very essential. BM should establish an online platform showing inspection timelines, incident logs like ship collections, and engineer licensor details, updated quarterly to build trust and uphold high ethical standards. Okay, now I will move on to the next topic, which is conclusions of the Francis Scott Key Bridge collapse incident in 2024. The March 26, 2024 Francis Scott Key Bridge collapse triggered by the Amphidalis collision was a stark reminder for our responsibilities. It claimed 6 lives, disrupted supply chains, and caused billions in damages. Outdated protections, like ignored safety recommendations and lack of transparency, fueled this failure. Therefore, our recommendations, aligning with the Registration of Engineers Act 1967 and BM Code of Professional Conduct, was developed. By adopting these measures, we can strengthen infrastructure, uphold ethical responsibility, and prioritize public safety to prevent future tragedies. Thank you for listening. Let's commit to these changes to ensure Malaysia's infrastructure is safe and resilient.